Hello everyone, welcome back. So now let's talk a little bit about material condition modifiers and how they affect straightness. Now we can apply either the max material condition modifier or the least material condition modifier if we're controlling a feature of size with straightness, which will be only cylindrical features of size. What happens is if we depart the least material condition or the max material condition in either of these cases, then I get more form tolerance. I get a bonus tolerance. Now, a way to understand where you're getting this bonus tolerance from is to first talk about something called the virtual condition. So the virtual condition boundary is created when my tolerance with the MMC or LMC modifier, and it's applied to some sort of feature of size. So, for example, the straightness applied to the max material condition on an external cylinder, so a shaft, well, that's going to be a perfect cylinder that has the shaft's max material condition and size plus the straightness tolerance. This is the virtual condition. So this is not the same as that perfect form boundary because it's also including the form tolerance. And for a least material condition, the virtual condition would be the least material condition size minus my straightness tolerance, which I don't see nearly as much, honestly. That one, you don't see it used as much. There's times for least material condition, and it works. It's fairly rare here. We'll get to some great examples of this when we get to position tolerance, though. Okay, now, bonus tolerance is not actually the technical word. It's additional allowable tolerance. So this is simply the specified tolerance, which might be like 0.006 if I have straightness. Let's just go ahead and write it out. And I'll do it correctly. I should have had a diameter symbol in here. Let me do it all the way through. So let's see, diameter symbol 0.006, max material condition modifier. There we go. So your base tolerance is this. You get that even if you're at the perfect form boundary. Perfect form boundary doesn't exist anymore because you have you're doing axis control here. You're controlling the axis of a feature of size, and so you'll always have this 0.006. Now, as I leave my max material condition, so as I go away from the virtual condition, which is that max size that could ever possibly be, including form tolerances, like this is the max variation, I gain bonus tolerance. I gain bonus tolerance until I reach my size tolerance. Eventually I'll reach an upper or lower limit based on the size tolerance, and then at that point I have to stop and I don't gain any more tolerance. So I'd like to look at an example of that with you so you can kind of see what the virtual condition is. You can see what I mean by bonus tolerance. So right here I have a cylinder. And that cylinder has a diameter of 1.25 inches plus or minus 0.01. So the biggest it can be is 1.26. I've also applied a straightness tolerance of 0.007, and I've applied the max material condition modifier. So having applied this straightness tolerance, it already means that, I don't have a perfect form anymore. This can be curved as long as it doesn't break my straightness tolerance. So where is that straightness tolerance going to come in? What is that virtual condition? Well, the virtual condition is like me taking my max material condition, which is 1.26, and I add on the 0.007, and I make a perfect cylinder of that shape. So it's 1.267 in diameter. And then I say that, okay, even if I'm at my max material condition, as long as it could fit through this cylinder, it hasn't curved enough to be of breaking my straightness tolerance. You can see that right there. The straightness tolerance right here is at its max. It's a max of 0.007. That's as much as it gets for this size, and it hasn't broken that boundary. So virtual condition is just a special boundary that takes into account the max material condition size and my straightness tolerance. But here's the cool thing. As this diameter gets smaller, well, there's more wiggle room. I can get more and more curved and still fit through that virtual condition because the virtual condition doesn't change. And you see that right here. So at 1.26, which is my max material condition, I get allowable tolerance of 0.007. But as I get all the way down to my least material condition of 1.24, I get a allowable straightness tolerance of 0.027. So that has almost quadrupled my tolerance, which is amazing. And it will still pass. Like, its form is good enough for it to have the same function of most likely fitting through a hole. So maybe this is like a long shaft that's going to be used to connect several pieces together, and it has to fit through the holes. Well, the smaller the shaft is, the easier it will be for it to get through every single hole. And as long as it doesn't go beyond the least material condition, well, everything should be fine for stresses and strains and other things that are controlling it. So I hope that helps you see a little bit how the virtual condition works. I will promise I'm going to be doing some application problems of that, so you'll get to see it in action a couple more times. Thank you for listening, and I'll see you all next time. Bye-bye.